we can find the derivatives of things that aren't even functions. But to do this, we need more special tricks. To make the equations easier to read, we will use y to stand for the derivative with these. So, say you have an equation like x to the 5 plus 3xy squared equals xy to the 6 plus x squared. It would be pretty tough to solve for this y. That is, to make it look like y equals something. Can we ever find the equation for the derivative of the messy equation above? The answer is yes. The trick is to this thing of y as being a function of x. We can't explicitly work out what a function is, but we can say it exists and use it implicitly as y. So anytime we have a y, it is like the outside function is some unknown function of x hiding inside. Let's look at the second term of the messy equation above, 3xy squared. Instead of the way it's written, think of it as 3x times some messy function of x squared. So we have two things multiplied together, for that we need the product rule. And one of the things that are multiplied together is a function from outside and an inside part. For that we also need the power chain rule. Remember, for the product rule, f of x equals g of x times h of x, then f prime x equals g h prime x plus g prime hx. The power chain rule is if f of x equals h of g of x, then f prime x equals h prime g of x times g prime x. So we go along working on the terms. The derivative of x will be 1, and the derivative of y will be y prime. If we just write this on the 3xy squared term, we will get 6xy y prime plus 3y squared. Okay, in the second part, g prime of x plus h of x, we have the 3, and the derivative of the x term, that is 1, and the y term, that is y squared. So that one's pretty easy to figure out. In the first part, g of x plus h prime x, we have 3, and the second term x, that is x, and the derivative of the y term, that is 2y y prime. When you put all that together, you get 6xy y prime. But let's look at the 2y y prime section again. Just how did we get that? Okay, we start with y squared, and think of it as some messy x thing squared. When we take the derivative, we get 2 times some messy x thing squared, x is not squared, times the derivative of the messy x thing. The name for some messy x thing is y. The name for the derivative of some messy x thing is y prime. Put that all together and we get 2y y prime. Multiply that by the 3 and the x and we get 6xy y prime. And that's it. So let's take a run at the whole problem. Find the derivative of x to the 5 plus 3xy squared plus xy to the 6 plus x squared. Taking the derivative of each term, 5x to the 4 plus 6xy y prime plus 3y squared is equal to 6xy to the 5 y prime plus y to the 6 plus 2x. Now what? Well, we're looking for the derivative of y, that is y prime. So put all the terms of a y prime on one side and everything else on the other. So here we have 6xy y prime minus 6xy to the 5 y prime equals y to the 6 minus 3y squared minus 5x to the 4 plus 2x. All we have to do now is factor out the y prime, and so we get y prime times 6xy minus 6xy to the 5 is equal to y to the 6 minus 3y squared minus 5x to the 4 plus 2x. Multiply both sides, 6xy minus 6x times y to the 5, and the resulting expression is y prime is equal to y to the 6 minus 3y squared minus 5x to the 4 plus 2x divided by